Welcome to EDU-VALUED Academy, where education is evaluated. In my last class, I discussed about up to 3 terms of an algebraic expression for the factorization. Today I'll finalize the methods of factorization. Today I'll talk about 4 terms, as I have already told you all about 3 terms. The basic and the foremost method of factorization is to express an algebraic expression into their products. Sometimes an algebraic expression consists of more than one terms. That is the reason we put bracket. And this bracket gives us the concept of factors. Whenever we create a common with bracket, that common will automatically become a factor of that polynomial. That's what I told you all today. For 4 terms, excuse me, for 4 terms, first method is again the same, take common out. Like if there is an expression of algebra and every terms is having a common factor, so definitely we will take it out to create a bracket, and the bracket will give us the indication of factor. Next one is grouping them in 2 to create a common. To clear your concepts fully, you please write down this procedure. Earlier I think you have come across those procedures number wise, so that you will never be in trouble while factorizing an expression of algebra. So first take common out, then grouping them 2 to create a common. Take common out. If I give an example, let's say here, you see this is x to the power 4 plus x cube plus x square plus x. Here you see in every term the common is there. X is common factor because x divides each and every term clearly. So we will take x common here. If I take x common, so automatically x will be the factor. One other factor is x cube plus x square plus x plus 1. Now the second procedure is, maybe this will not be the question, but you have to group them. Next one is grouping them in 2 to create a common. Here you come down again. You see there are 4 terms. Here x in every terms. We have x. So we have taken x common to have a factor, and this is also a factor. Now there are again 4 terms remaining. Now asking you to arrange them in 2 groups to create a common. Let's see. Here x, you put a bracket again. Then these 2 terms, if you group this together, this is already grouped, I think. If you take x square common, so this will be x plus 1. So automatically this is x plus 1. So if I take 1 common here, so this is again x plus 1. So see, we have created a common here. We will take it out. So x into x plus 1, again x square plus 1 is remaining here. So this is x square plus 1. This way we have factors here. We have 3 factors here. Okay. So this way we have this, how we can group them into 2 to create a common. This is the concept here. Second point. And third point is try to have difference between 2 squares. How I will have difference between 2 squares, like sometimes you may face this type of questions like x square minus 4y plus, this is your 4y square, this is plus 4y, and this is your minus 1. You see here, there are 4 terms, and this y is already linked with this whole square one. This is square term, perfect square, and it is also perfect square. So you can easily arrange this into 2 squares like how it is. So x square, if you take minus common, this is 4y square, this is minus 4y plus 1. So that means this is nothing but 2y minus 1 whole square. How I will come to know that this is a perfect square? You see, this is the perfect square number, and this is also perfect square. 1 is perfect square number and 4y square is also perfect square, and this is the square of 2y. If I multiply this 2y and 1 into 2, this will be 4y. So definitely this is also a whole square. Let me show you here. You come down, x square minus 2y minus 1 whole square. Once I have got the difference between 2 squares, so we have an identity here. That is a square minus b square. Here we have this identity here. A means the first term and the second term. This is a plus b, first, second, first minus second, a minus b, this way. So again we can write this one very nicely. So x plus, once we put plus, so there will be no change of sign. 2y minus 1. Again x minus 2y, this will be plus 1, because once we are multiplying with minus, so this sign will get changed, and that is the reason this will be minus 2y plus 1, and this x plus 2y minus 1. Bit hazy, but those who want to know it perfectly, so they will eagerly follow my lecture, and I will expect you to follow this lecture so that there will be no difficulty at all ahead. Please, the next one is use identities for 4 terms. And I think those students who are already securing very high percentage of marks, and also who are extraordinarily brilliant, they knows there are 4 terms. That means that 4 terms will give us a whole cube, because a whole cube consists of 4 terms, 2 perfect cube terms, and then that heterogeneous terms, that means is a conglomeration between 2 different terms. Let's say how that is also known to us. That is, if I clear you, so here please let me show you the identities, how I will use identities for 4 terms. Then I will finally talk about the last and final, that is factor theorem. Let me discuss about the creation of whole cube. If it is 8x cube minus 12x square plus 6x minus 1. You see 1 plus 1 minus, 1 plus 1 minus, so definitely it will never be a whole cube of a sum of 2 binomials, but it's the difference between 2 binomials. That's what one positive, negative, positive, negative. So definitely this is, now you see this is whole cube, perfect cube. This is a perfect cube number, and this also we can write, this is also perfect cube. So this is minus 3, the first one, and it will be reduced, your exponent will reduce here. This is 2x whole square into the second one, this is this one, plus again 3, the first one, and the second one whole square. So you see, just we have this is 12x square, this is 6x, and this is minus 1. So definitely this is nothing but 2x minus 1 whole cube. So already we have three equal factors, 2x minus 1, 2x minus 1, and this is also 2x minus 1. This way, this could be factorized. That means this is a number of 4 terms, and the last and final one is the factor theorem. Factor theorem, forget, we have to try for zeros. If there is a polynomial of degree 1, degree 2, 3, 4, and of single variable, one variable, then we will put values for those variables accordingly, plus minus 1, plus minus 2, plus minus 3, so that we will get a 0. Once we will have 0, and that will indicate as the factor theorem, and thus opposite of that sign with the variable will be the factor. Let's see how it is. So the last and final method of factorization, that is your factor theorem. Then I will talk about these two problems. These are very important problems, and next I will tell you what the factorization of cubic polynomial. How to factor cubic polynomial without division. That also I will tell you. Now here we have factor theorem. Factor theorem, the last and the foremost theorem for factorization is factor theorem. Let me discuss about this. Let's say this is your x square minus 2x plus 1, that's what key. Because this is a perfect square, if you just try to remember, this is a whole perfect square number and this is a perfect square number. If I multiply the 2 with the square root of this and this, that is 2 into square root of this one is x and square root of 1 is your 1. So this is 2x. So this is obviously, this is a whole square, that means x square, and this is plus 1 whole square. This is your x minus 1 whole square. So I have told you already, this is for binomial, this two will be the factorized by the using of identity. But here what I want to say is some bit different. Different means how, you see, here if I put x is equal to 1, putting x is equal to 1, x is equal to 1. So now 1 square, this one, minus 2 into again 1 plus 1. So this is 1 minus 2 plus 1. This is your 1 plus 2 is 2 minus 2, 0. Once having 0 for x is equal to 1, it is 0. So definitely x minus 1 is a 0 of this polynomial. That means x minus 1 is a factor. If I factor means what? I told you already. That means this expression will divide completely this expression, algebraic expression. That is the reason this is the factor of this polynomial. That's what we have factor theorem, right? So this is your what we want to know. That means anything we can, for any factorization we use factor theorem. This is ultimate theorem, universal theorem, as people know. So like even if it is x square plus 2ax plus a square, now you see the condition here. If I put here x is equal to minus a, so this polynomial will be 0. You see, this is minus a whole square means positive a square. This is plus minus 2a square, and this is plus a square. So definitely 2a square minus a square, this is 0. So for x is equal to minus 1, it is 0. So definitely x plus 1 is a factor of this polynomial. And we know already this is nothing but x plus 1 whole square. That's what we know. And that is two equal factors are there. There is a perfect square, and these are two equal factors. And here we have this one by factor theorem. We can factorize any algebraic expression. Let's start with this two very important problem. Is a power, fourth power. Normally we have one identity a square minus b square for two terms. Here this is two terms. This with exceptional cases is here. Here you have to use this identity a square plus b square. This is your, either we can write a plus b whole square minus 2ab, or a minus b whole square plus 2ab. This way we can write this identity. Here also I will use identity. With the help of identity, I will just solve this question. How you see? This is x square whole square plus 2y square whole square. Now if I use this identity to have minus, that means difference between 2 square, I will expect it will be expressed in the difference between 2 squares. So this is your x square plus 2y square whole square, a plus b whole square minus 2 into a means here x square and b means here 2y square. So here it is x square plus 2y square whole square minus 4x square y square. Again I can change this into whole square, that is your this one minus 2xy whole square. So obviously this is the difference between 2 square. Now we don't have any hassle. This is this plus 2xy and this is x square plus 2y square minus 2xy. Now you please do try this question also, so that if you use here a square plus b square identity, you take it this side and it will be also converted into this x square plus 1 whole square minus x whole square. So you try this in your home. This is your homework. So that you have to use this same identity, here a square plus b square and here a square and here b square. You take it this side, this, and then adjust, though you will get finally this one. So this is what we have for this. These are the very special cases of factorization. Now, it is a cubic polynomial, but the standard form of cubic polynomial is your a x cube plus b x square plus c x plus d. Here a, b, c, d are constant integers. A cannot be equal to 0. If a becomes 0, then this will be a quadratic polynomial. So obviously here the restriction is that a cannot be equal to 0. This is a standard form. This is the standard form of cubic polynomial. But here x square is not here. As I told you, I will use factor theorem, and without division, you see how I will solve this problem. Here this is y. This is y cube minus 7y plus 6. So let me explain this one. If I put the coefficient of y cube, coef of y cube 1, coef of y minus 7 and constant c. Constant is your 6. These are all three terms, sum of these three terms. That means here whatever is given, the sum of these three terms is 0. If I take the sum, if I add this whole, so definitely this will be 0. Once we will get the sum of these coefficients as 0, we will be sure 1 is the factor of this 1, that means for 1 is one of the 0 of this polynomial. If 1 is the 0, that means if I put 1 here, let's say 1 cube minus 7 into 1 plus 6, this is 1 minus 7 plus 6, this is 0. So definitely we have 1 as the 0 of this polynomial. So definitely by factor theorem, x minus 1 is a factor. Y minus 1 is a factor. Y minus 1 is a factor of that polynomial. Factor. Once we have come to know y minus 1 is a factor, and we know To take common out is a process of factorization. So I will just write this expression how you just follow, and then you don't have to divide and you will get the factor very easily. How you please follow till the end. Plus 6, you leave one line, next you write 3 factors. Once you have come to know y minus 1 is a factor, so you write 3 times y minus 1 because this is degree 3. Now to get yq you multiply this one. Now you multiply this yq, and this is minus y square, but y square, there is no term y square here. So balancing plus y, you multiply, this is plus y square minus y, but instead of minus y we have minus 7y, so we need minus 6y. So here you put minus 6, so this is plus 6. If you multiply, so this will give you plus 6, so this is balanced. Now you see, without division cube we can factorize this way. And now you go for middle term spreading factor. That's what I told you regarding 3 terms. This is 2, 3 into 2. If you take LCM, 2 factors, 3, 2, and 3 and 2 will give me 1. There is 1 coefficient and positive 1. So definitely plus 3, and this is minus 2. So I can factorize this one with the help of that one. That is y square plus 3y minus 2y minus 6. Here you take common from these two, you will get the factor. Y minus 1, this is y common, y plus 3, y plus 3. So here y minus 1, y plus 3, and the remaining y is 1 minus 2. So this is y minus 1, y plus 3, y minus 2. So this is what the factors of this cubic polynomial without any division. Now let me give you another example, because this is a universal method. This will be applicable anywhere to have factored. Like this expression of quadratic expression, x square minus 5x plus 6. Here I am putting x is equal to 2, this is 2 square, x is equal to 5 into 2, 10, and this is plus 6. So definitely 4 minus 10 plus 6, and 10 minus 10, this is 0. So we have come to know x is equal to 2. That means 2 is a 0. So x minus 2 is a factor of this polynomial. Let me, without, even if you don't know even the middle term spreading factor, once you have come to know x minus 2 is a factor, you write twice. That's what I told you. Because degree 2, now balance, x multiply, you leave one line, this is x square, and this is your minus 2x. So we need minus 3x again, so you put minus 3, here minus 3x plus 6. This way it is x minus 2 common and x minus 3. Even you know middle term spreading factor or not, you can use this technique for the factorization, that is factor theorem. Anyhow you get 0, and once you have got 0, you just convert it into factor, and then write step, leave one step. The next step you write according to the degree. If it is 2 times, if it is 3 times, this way. So you don't need to divide at all. You just please carry on with this one. If you don't understand, my email ID is there. You can have consideration from me without any charges, without any fees, and I will clearly explain this one. If you feel like this will be enough for the factorization of an algebraic expression, then do subscribe my channel, and please help your relatives, kin and kids, and also your brothers, sisters, whoever have been pursuing this under secondary level. They will be very much helpful. So I do hope you will share this video to every friends and every near and dears. Thank you.